In this session, let us solve this question from JEST 2024. The question is from op-amp. The given circuit is a very standard circuit. It is the circuit of an inverting amplifier, and for inverting amplifier we have the relation between output voltage and input voltage. Vout is equal to minus RF divided by R times Vi. Here RF is feedback resistor is equal to 25 kilo ohm, and R is nothing but 10 kilo ohm. Vi is given to be 0.5 volt. Therefore output voltage is coming out to be equal to minus 1.25 volt. Now let us say you do not remember this formula, you do not remember the standard circuit. Then what will you do? You can use virtual short. If there is a negative feedback, here you can see the output is taken back to the negative terminal. Therefore here we have a negative feedback. When there is negative feedback and the operation is in linear region, then the difference voltage is approximately equal to 0. Now what is difference voltage? It is the difference between positive terminal voltage and negative terminal voltage. This is approximately 0. From here we have V plus approximately equal to V minus. This is called virtual short because there is no actual physical short between negative and positive terminals, but still their voltages are equal. Therefore it is called virtual short. Now if one of the terminal is grounded, like you can see the positive terminal is grounded here, in that case the other terminal will also be grounded. This is called virtual ground. So V minus, which is not actually physically grounded, but because V plus is equal to 0, the negative terminal is also behave like it is grounded. So V minus is equal to 0 volt from virtual ground condition. Now we will use the Kirchhoff's current law here. Kirchhoff's current law says that the sum of outgoing currents is equal to sum of incoming currents. So outgoing current, let us say this is I1 and this is I2. Now in this direction current will not flow because for an op-amp the input resistance is very high, and therefore current will not enter into input terminals. Therefore we have I1 plus I2. This is the outgoing currents. This is equal to 0 because there is no incoming current. Now I1 is nothing but, let us say the voltage at this point is V minus. Then we have V minus minus Vi divided by R. R is 10 kilo ohm, plus I2 is V minus minus V output divided by 25 kilo ohm. This is equal to 0. Now V minus is equal to 0 according to the virtual ground condition. From here we have minus Vi divided by 10 is equal to V output divided by 25. From here also we will get V output is equal to minus 1.25 volt. Now let us find the current flowing through this 10 kilo ohm resistance. It is asked current I in the 10 kilo ohm resistance. I is equal to, let us say current is flowing in this direction, then we will have V minus minus Vi divided by R. This will be the current. V minus is 0, 0 minus Vi is 0.5 volt divided by R is 10 kilo ohm. So this is equal to 50 microampere. Now we assumed the direction of current to be in this direction. This minus sign indicates that the direction we assumed is incorrect. The direction should be this direction. It should be flowing in the opposite direction. Therefore the correct answer is option A. We have 50 microampere as the current and V output is minus 1.25 volt.